Shut up and sit down.
Hi everyone, welcome. I am KiteCraft. I have a very special session for you this afternoon. This afternoon, if you can see on the right hand side, I'll actually be developing some new code for this little project I have here called HardSense. This particular stream is a whole new type of stream for me. So I've been trying to do some project streams. I did a drill press earlier this week where I tried to actually do a prepared project. I've been doing some live streaming some video games. I've been trying to figure out how do I actually get across what these projects are that I've been building. And instead of trying to just put something together at the end, I thought it might actually be better to show you how some of this development is actually being made. In the top right corner, you're going to see this really interesting thing called an ESP32. If you're familiar with what that is, fantastic. If not, well, there it is. In the top left, you're going to see this little display. It's called a TFT. And this is using the Bodmer's library called TFT-ESPI for doing some visual displays, which is really cool. I'm going to show you some more of that. We're going to be developing code in VS Code. This is Arduino code that I'm just writing in, not the expressive project SDK. And let me see. So first of all, let's actually have a look at what's kind of going on here. I'm going to give you a quick overview of just what it is that HardSense is that I've been talking about for the last quite a while. Now, I got to remember I'm talking up there to okay, let's get rid of that. So there it is. This is HardSense. In the top right corner, we have an ESP32 dev kit. It is in fact running at this is an Arduino type. You can write this in Arduino, but this is a 256 megahertz dual core microcontroller with Wi-Fi and Bluetooth and USB and a crap load of pins. Sorry for the language, but there's a whole bunch of pins coming out of this thing, and it is absolutely awesome. And like they're under $10. So why would you not want to use these? In the top left corner, we have this display. It's that TFT ESPI. It is in fact a touch screen. In the bottom, we have the little RTC, which is a real-time clock. We got a little blue button in the middle, and over on the right is a Rotary encoder. Anyways, I'm just sort of trying to figure out this stream, so welcome. If you're going to join the stream, say hi. But anyways, what this is really showing you is that, in fact, all of your sensors inside of your computer. Okay, let me start over. All the sensors that are built inside your computer, there are way more sensors than you might actually think there are. Oh boy, where'd it go? You know, I even did some practice sessions on this, but when you still go live the very first time, it's really hard. All right. There we go. So what I'm actually going to go through today is this little project called HardSense. Your computer has a whole bunch of sensors in it like you wouldn't even believe. For example, if you're a gamer like me, you're going to be looking for things like your video game's frame rate. Your GPU is going to be putting out temperature and fan settings. And if you're a particular type of person, all of these sensors are actually going to be quite valuable to you. So you might have things like your task manager will be open in a window. You might be using EVGA precision software to have some displays up, and you know they always have another monitor with a dedicated display for all of these sensors for you hardcore gamers, and you know what I'm talking about. I myself do a lot of work in software and developing code, and I do some gaming like that. So I actually want to see all these sensors as well. But what I've realized is that it's a pain in the neck to actually have all of these different windows open, like a task manager, and having the EVGA Precision X open and having all of these other windows open. So what I've decided to do is I've actually decided to use some of my skills and take all of these things off of the computer, and I'm going to build a little special box. Now all I've been showing you is this really close-up view of the whole ESP project, but I'm going to try and give you actually a much wider view so you can see what's going on here. There it is. Nope. Now, I think what you're going to notice is that the sound is now a little bit out of sync with the video, and I'm really sorry about that. But over here, underneath all of these lights, is in fact a small little microcontroller. I'm just going to try and get all this in here. This is, I call it my voltage transmogrifier. This is actually just a DC to DC dual buck converters that I built inside. This is a whole other project. Whatever voltage you put in here, up to about 16, as low as 7. You have a 3.3 volt output and a 5 volt output. So this box, you can see where my hand is. This is about the size of what HardSense is going to be, but right now it's in its raw stage over here. You can actually just see the display. So I'm going to move my camera over this way. This is another one of the videos. Let me move that out of the way. Whoops. Sorry. Trying to do this for the first time. There we go. So now you can kind of get an idea of exactly how large this project really is, because there's my hand. And there's the ESP32. Whoops. There we go. Alright, I'm going to go put this camera back. So what was that all about? Well, actually what I'm trying to show you is just that yellow box is the box that's going to be sitting on my desk. And the cool thing about it is it's going to be completely wireless. Yep. There's going to be a battery inside it to power the whole thing. It's running off of an ESP32 and it's utilizing both the Wi-Fi and the Bluetooth to run. The Bluetooth is used for internal configuration, which is a really cool bit that I'll actually show you later on. But normally it will just sit there on Wi-Fi collecting data from another program that runs on the computer. The part that runs on the computer is actually called HardSenseESP, and that's a whole different project I'm going to show you in a bit. In the description of this video is a link to my GitHub repository. All of the code that I'm going to show you is in fact right there, including the main HardSenseESP project. It's all living inside a repository right here. This is my github.com KiteCraft HardSense. I'm actually going to be developing all of my code today on branch 13. If you go into the branches up here, I'm actually working on branch 13. This is the live branch. Let me go back to the root. Inside software, we have both the Windows application, which runs as a taskbar application, and it runs in the background, and it is just called HardSense. I will open it up real quickly. And right now, it is actually just a stub. It runs a thread in the background. Oh, pardon me. It runs a thread in the background which is monitoring all of my temperature or all of my sensors inside my computer, and it sets up a memory map file which it updates 4 times a second. Try not to overload in things, and that's a pretty high refresh rate actually. It also sets up a TCP server on a particular port. You can choose your port. It's up here in the settings, and as soon as any client connects successfully, it'll just spawn it off and it'll sit there as a nice proper TCP server. So as a client, and in this case, my client here is going to be the ESP32, or any client that actually wants to connect to this TCP server, you can actually just give it a list. Well, you can first of all, request a list of what all of the sensors are available, and it'll just give you a quick little jaunt. In this format right here, you can see on the right corner all of this box of data. Starting total sensors available 71, and goes through all the different fans that are available. And this is just a stub, but it sets up the TCP server, and all of these sensors are available as a request. So as a client, you can successfully connect to the server, which is the Windows server, and request, send me these sensor values, and it'll send them to you. And so then they're displayed over here on this. There. I'm having so much fun. I'm going to slow down here a bit once I get into how to do this. This is my very first time trying to run this stream, so you know what? I don't know how far I'm going to get. I might just use this as a practice and come back later this evening as I kind of figure this out, because, you know, you practice these and life goes to hell, doesn't it? Anyways, the final HardSense project, the ESP part of it is actually this little beautiful touchscreen, which I'll show you once I get some better lighting on it again. There, hopefully that helps. And that's the bit that I'm going to be working on today, is showing you how to do some of these screens, but they're really cool. And then you can, of course, do a whole bunch more things. So this actually just runs as a tray application on my computer. So when I hit close, it doesn't actually close it, it just minimizes it down to the tray. Inside here, ESP32, this is what I'm working on today. Now, the Windows application is meant to be built and run as a it's a Visual Studio community project, VS Studio. And it's wonderful. I love working with that. It built a beautiful little application. And the cool thing is that I can actually do all of my IoT development in it with something called Visual Micro. And I gotta tell, no affiliation, like seriously. Sorry, I just got a little worm in here. I think it's just me. No affiliation to anything that I'm talking about. This is all my own development. Nobody's ever told me to do anything or anything, okay? No disclaimer, I'm by myself on this, so I think I have to say that. Unfortunately, I lost my train of thought. Okay. Anyways, okay, Visual Studio. I gotta check my notes there. Visual Micro, and it was a beautiful way to do Arduino development in Visual Studio, and it made it a single project for everything I could fit in, and it was wonderful. It was a trial license, or it was a free license. I guess it was a pared down part of their product. I still can't afford to buy it, and I was quite happy with it. I was using it to do this. I wasn't trying to make money off of it or anything. And then one day it changed. I did an update and the licensing changed. I said, okay, they know there is no pared down version that I could continue to use. It was like, okay, you've run out of time. You got to pay up. It was like, oh, okay, crap. It was just a slight, I didn't realize that was going to happen. Well, I probably did, but I don't know. Anyways, got all confused. But anyways, I had to switch this over to VS Code. So I've been trying to use VS Code now. And I just started using VS Code yesterday to flip this over. I was really annoyed when Visual Micro did that to me. You know, there's a whole story behind that. But no, I loved using it. I really want to get back to it. So I did a bit of things. So now I'm into VS Code, trying to figure out VS Code to get my Arduino development going. And that's where we can actually go back up into here, into the ESP32 project. And this is where you'll see all the stuff I'm working on today. And this includes some really interesting bits, including the Bluetooth configuration and things like that. But what I really want to do is add a few new screens to this. I'm going to go ahead and switch over to the actual display now. If there's people here, ask me questions. Like I said, I'm actually probably just going to do this as a bit of a practice, so don't waste your time. I have a whole bunch of work to come up. My goal of this is to actually finish building this project, and I was going to live stream the whole thing over the next few days. This is step one of that. I have a little bit more code to write, but basically the ESP32 is done, and basically the Win32 or the Win64 project is finished as well. The next step is just to do some tidying up and some refactoring and adding some final bits, like the Bluetooth connector screen, something nice and flashy there, and a general splash screen, and just to pretty up the actual startup of it, which I'll show you all in a minute. And then I have to actually go ahead and finish. If we go back to the base of HardSense here, and we go into the hardware bits, so I've already started with the actual schematic and PCB board. I think I have some pictures in here. Yeah. So this is actually what the HardSense board will be like. That's a bad picture. Let's try this one. There we go. Wow, that's just horrible, isn't it? So, let's try this one. Nope, that's the step file. That one. No. Anyways, you go look. So that's the next final step, is to actually make that circuit board, which I'm going to be finishing doing. And then we're going to go ahead and design and build the actual enclosure and 3D print that. That's what that little yellow box was that I was showing you a bit earlier. Where'd my other one go? So this yellow box right here that I was showing you earlier, this is about the final size of the box that I'm going to have to design as the final step. So finish a bit of code, finish off the schematic and the circuit board, build the circuit board, design the box, put it all together. I'm going to do that over the next few days. I've actually spent most of the preliminary work is done, so this is really the home stretch. However, I have to make a couple changes because it's getting really warm and I'm dying. So we're going to switch back over here to the desktop. There we go. Anyways, github.com, KiteCraft. Go there. Let's go back to my root. Repositories, HardSense, P-board, that's a whole different project. It's actually going to end up being used inside the same box. That's pretty cool. There's a couple things going here. And these are my KiCad libraries, but we're going to just go into HardSense and everything is in there. All right. Playbacks. Okay, hello. Nobody's chatting. That's fine. Okay, let's have a look at the right. It is time for me to have a little bit of fun, and I'm actually going to show you the most fun part of this whole project. Starting with the actual HardSense. So I'm going to go to my overhead tablet. I hope you can see what's going on there. Now remember, this is here's my finger. Ooh. The other clean. Stick my finger under there. Okay, so yeah, you can see what's going on. Now I'm going to stand up. I'm trying to do this without touching anything. In the top left corner, I've divided this all up into widgets. Hang on, I got to do something. Sorry about all that. I do have a Patreon account, a PayPal me. I'm trying to raise money so I can actually start doing this a little better, get a whole better setup to actually run this shenanigans. Anyways, let's have a look at what's going on here. Sorry. It just really... I don't know what's going on with the sound here. Is everything good with the sound? If anybody is listening, how does it sound? Anyways. So in HardSense, as you can see, each of those blocks, I've divided them up into individual widgets. Yeah, sorry. Into individual widgets. Why is the time setback? Oh, that's why. We're going to have to set that. You notice the top right-hand corner of the time is way off. That's okay. I know why that is. We got my net. So that's my up and down. You can see the arrows. It's supposed to be a green arrow and a red arrow. Green arrow is up, red arrow is down. And then the RAM usage, that's my overall system RAM. On the top left corner is my CPU widget, and that contains the overall load. That's your CPU percentage. The temperature, the wattage is the total package wattage that's available as a sensor value. And then, of course, the overall clock speed of it. And then, of course, the same with the GPU. This GPU is a NVIDIA GTX 1080 Ti. And it's running, wow, 44%. And, okay, so something is wrong there. Why is it running at 29 degrees? So sometimes EVGA breaks. Let me just check to see if that's actually working. Yeah. Okay, good. That's one of the things that this is actually helping me figure out. Sometimes I'll look at this and the fan percentage will be 0 and I'll know EVGA crashed. It does that quite often. Well, not quite often, but it happens. And then across the bottom is just like various hard drive free amounts. But the really cool thing is that if I touch, this is a touch screen, so if I can just click on that. This is now the last screen I was working on. This is my individual CPU screen. This will graph all of the CPUs. In the top right corner is the overall package percentages, and then each individual core is split up into its own speed, temperature, and overall load. So this is actually a hex core hyper-threaded CPU, and you can see it's running quite well. The overall package and core wattages can be measured independently. Now, I'm not doing anything special about this. These are all sensors that are available on any particular computer. And when you run the HardSense 64 application that is the other side of this project, it'll actually give you a list of all of these raw sensors that are easily available to read in your computer. there's 71. There's actually a few that I specifically wrote, and I'll actually talk about the library called the, where to go? I should show you that before I go too much further. So if I go back up into HardSense, into software, Windows, this fella, I've actually had to make a clone of this, and I've actually made a few changes to the open hardware monitor, but the original open hardware monitor really is cool once you get to know it. It takes a bit of work to figure it out, but it's really useful. So this is my attribution to him, or her, whoever wrote that. It's a great library to use, and I've been using it a lot. I'm not even showing you the right thing, sorry. I am failing dramatically, aren't I? Sorry, I thought I was displaying this. I am so sorry, I suck so much at this. Wow. He's been staring at that little monitor, which is pretty cool. And I've actually been clicking away over here. I'm really sorry about that. Let me go back up. So this open hardware monitor, I've got full attributions to this fella, the person that, or whoever, wrote and distributed this. But you have to use the bit that comes with HardSense, because I actually have made some changes to it, with enum types, in order to stuff in my own frame rate counter and something else. But anyways, let's pop back into the HardSense. Now, on any other screen, except for the home screen, on every other screen, the bottom right corner is always the back button. So if I just touch over here, or sorry, it's always the home button. So that'll just take me back to the home. Now I can click on the GPU. Now that pulls up my specific screen from my GPU called the EVGA, and it's got this little 90-second graph, and this is my temperature and fan. Now I'm not actually doing anything with it. If I started up a game, you'd notice that would just kind of, do its right thing. So even though it is actually using a high percentage, so-called, of the core, you'll notice the actual clock speeds aren't moving. So it's not really using any effort from the core. In fact, if you want me to prove that, here's what I'm going to do. I'm going to open up. Now you just keep an eye on that. I'm going to open up a video game, and let's see what happens there. What should I play? I'm going to play Black Mesa, and we're just going to keep an eye on what's happening there. Come on now. And you'll see that this really is a live action. Those values really are being, come on, over here. Live updated. There we go. Okay, so just getting it over here. Now you can actually see that the core memory's popped up. Let me switch. Get some temperature going. I'm going to switch over to this camera. Hi. So we'll just play a little bit of this video game, and you can see in the top or in the below me. Just keep an eye on that monitor. Look in. Okay. I don't know. Can you hear me? I don't know which microphone I'm using here. Hi. Okay. So what's happening with my HardSense over there? You can see the temperatures and values are going up, right? Let me just switch over to that again. Now this game isn't entirely intensive. I could have picked another game, but it would take a lot longer to load and do all that crap. But, it is, in fact, giving a live stream, so I'm just going to quit out of the game now. Let's go back to... Hi. So I'm just going to quit out of this. Don't save. So that's HardSense. What I'm actually going to be working on today is we're going to be adding a couple of new screens. Because if I bring up the HardSenseESP or Win64 project, there it is. Okay, well, first of all, let's switch back over to HardSense itself. I'm actually going to restart this. Now, what you're going to see, you know what? Yeah. What you're going to see is it's going to just power on. It's going to connect to the network. It's going to connect to the HardSense 64 server that's running on this computer. Let me go to this camera. This thing right here. This is my HardSense 64. Whoops. There it is. So don't do that. Okay. Where'd my OBS go? Son of a stupid. What the hell happened? Everything just disappeared on me. Sorry, I suck, I know. Anyways, I'm going to reboot this thing, and you're going to see what it does is it connects to the network, connects to HardSense, this thing 64 that you're looking at, this thing right here. It's going to request some data, and it's going to load up the screen. And you're going to see how fast it goes. It's pretty cool. Watch this. Push the button. There we go. It cycled through all of that. Now you might be thinking, well, that was a soft reboot, so that might not actually be fair. Well, let me see if I can just move this over. So this is, it's actually being powered from this thing over here. It's got 3.3 volt output. And you can see it goes over there. And then it's just powering everything on the board. And then there is, in fact, a USB power. In fact, you know what, let's just undo that. Oh, there we go. No, there we go. Now it's actually wireless. So, yeah. So I'm just going to turn it off. So what I'm going to be doing over the next couple hours with this project and with this live stream is I'm going to be adding some new screens to the display. I'm going to add a nice little splash screen, which has this little rotating graphic on it, and I'll show you where I got that from. I want to add a Bluetooth screen. This is called the Bluetooth configurator. Right now the configuration is done, and I'll show you in a minute, but all through this interface, but I don't have an interface on the actual ESP32, pardon me. So I just need to add a little bit of nice splash screens, and that's what I'm going to show you how to do. We're going to add some new screens, screen IDs is what I call them. Pardon me, and we're going to walk through that entire process. So let's go ahead and turn this back on, and you're going to see it connects to the network, connects to HardSense 64. That's the program that's running right over there. Requests its data, sets up the home screen, and starts streaming data, and it is so fast. So there you go. Now, what I'm going to want to do is, if we go into settings, this is HardSense. Once you compile this and got it running, there is the Bluetooth configurator. We can open that up. I'm going to move that over here. It's a little box. It tells us what all the ports are available. Now, this is where the little button comes into play. Over here on ESP32, you see this big blue button right in the middle? This is the configurator button for the ESP32. What will happen when I click that button, if we go over, oh hey, it's coding time, yay. What happens is when you hold that button down, the ESP32 actually runs a bit of code, and it says, where'd it go? Where's my mouse? Hello, mouse. It runs a bit of code. It goes, nope, we're not connected to anything. We're going to check, is the button pressed? Oh, yes, it is. So we go ahead and we start our Bluetooth, and then we handle our Bluetooth connection. So I need to add a screen for that whole Bluetooth connection. What is going to happen is the Bluetooth connection is actually where we allow, or we upload the SSID. You can see we have here the SSID and the password. That's the network information. We don't want to store those values, your network name and IDs, anywhere in any code, anywhere, for any reason. Don't ever do it. So in this case, we're actually taking advantage of the onboard SPIFFS. If you don't know what SPIFFS is for an ESP32, it's an onboard file system. This is a microcontroller. Look at this thing down here. I'm going to stick my finger in here. Boom. That's my finger. This thing has a file system. It's a microcontroller. It has a dual core 256 megahertz CPU. It has Wi-Fi. It has Bluetooth. It's less than $10. You know, when I started writing code, my computer wasn't as fast as that. My entire computer, and you know, for years, and the upgrades, and I love this. Now that I can use this and do such cool stuff with it, it's just wonderful. But anyways, I got off topic, didn't I? So, if you look below, if I actually go into the Bluetooth configurator, what will happen is I'm going to press the button, and I'm just going to reboot it by pressing this little button up here on the ESP. Yeah. So you'll notice there's nothing happening over there. shit. Hang on. I didn't have my terminal connected over here, did I? What the hell? There we go. There it is. Oh, okay. You know what? That didn't work. I didn't plug the USB in. So in order for all of this connections to work, I actually have to plug that USB back in. Never mind. No, wait a minute. What am I doing? Oh, yeah, the serial connection. But anyways, let's just get this connected. So this is running on port 7. I'll show you something that I actually missed. See, I don't have the USB cable connected. If you actually go look over at HardSense, where is it? You'll see it's just a black screen. So it's actually connected via Bluetooth to my computer. And that's what we're looking at over here. That's where this little box comes in. The ESP32 has a full Bluetooth connection available in it. And you connect to it and it acts just as a serial port. Oh, I love this. Bluetooth, Wi-Fi, actual USB, it's all just one thing. It's all just a serial port. And so if you write a library for one thing and it just works everywhere, it is so wonderful. You gotta love serial input and output. So that's all the Bluetooth is. So this is where you'll actually say, oh, here's what my SSID is, and here's where your password is, and this is the name of my computer and the port in which the TCP server, the HardSense server, is running at. Now, this is what it'll pull off of the actual ESP. Now, if I want to change it, I'll just add some new values in here and update it. It'll ask me to confirm it, and then it'll just rewrite it on the SPIFFS file system. And of course, if we actually go look at, I don't know, it's not in here. And it's the same with all the rest of it. We can actually update the time. Now, you'll notice, if we actually just, that I told you the box where the time was in the top right-hand corner was like way wrong. So I'm just going to update it right here. There. I don't even get any confirmation on that, but at least the time should be right now. So I'm just going to exit out of here. I'm going to go ahead and reboot this. You can see, look down below. Now I'm just going to reboot it. Where's my button? Push the button. Now, it'll boot, and if we have a look at it, it doesn't have the right time, you bastard. Make a fool of me? Alright, fine. Okay, so not doing anything there. Good. Let's go to my settings. Go to the configurator, connect. Yeah, there it is. So update. That should be all I have to do. Did I break something? No, I shouldn't have broken anything. Okay, let's exit. That's a bad sound, eh? Alright. Okay, now let's get back in and reboot this thing and see what we're looking at. Thank you. I think I rebooted it before it actually finished writing. So now we have the right time, Tuesday, February 11th, 1:33 p.m. Yep, that's correct. So that's the Bluetooth configuration, but you'll notice that the actual ESP32 itself doesn't have any screen for that, so that's what we're going to build. Okay. So I'm going to close this. So here we got, is the button pressed? If you were to actually open the VS Code Arduino project from my GitHub repository that I was just showing you, you will end up with opening, I can close all of these, but it's where I'm working. You will end up and see HardSenseESP. Now, disclaimer number 62.8. I am no expert at any of this. No, I'm not. Everything I do here is just stuff I've just pretty much taught myself. Okay? I've tried to learn as much as I can, and I learn what I need when I need it. And that's the coolest thing about these hobbies with the microcontrollers the way they are now, is and the wonderful libraries, is that once you develop some basic skills, you can actually just take advantage of all of these wonderful little systems and do some really neat stuff. So yeah, I am no expert. I don't know what I'm doing. If you look at this, it might, and you know what you're doing, and you're one of those people that actually has a clue, and you look at this and you laugh your ass off because it's shit. Okay, I agree. It might very well be absolute shit, but you know what? It's shit that works quite well. So I'm going to go with it. Now, this over here, I haven't even talked about it yet. This thing. That's a rotary encoder. You know what a rotary encoder is. If you don't know what a rotary encoder is, go look it up. But please come back and subscribe. This is actually volume control. I can actually use it to control the volume of my computer. I only have headphones connected to it, but and it's actually displaying over on the other monitor, so you can't even see it, but it does actually work. Yeah. So I can see, I used to have a Logitech keyboard that had a scrolling volume control on it, and I really loved it. But I've since switched to a different keyboard, which doesn't have any of those fancy little buttons, and I miss my volume control. Oh my gosh, do I actually miss my volume control so much. So what I wanted to do is actually build a new volume control into HardSense, and that's what this is. This is the volume control. I turn it one way, my volume goes up. I turn it the other way, the volume goes down. So that'll be part of the box. This box. This is about the size of the box that HardSense will live in. But if you've sort of paid attention to what I just said, that's a volume control. That means this thing is actually capable of sending data back to the HardSense application, which is the TCP server I was talking about, that you can connect the client to this. And you can actually send back requests for things like volume controls or media playbacks or, you know, whatever you want. Yeah, it works both ways. Keyboards, keys, there's a whole bunch of powerful effects going on available there for you to mess with. I'm not even showing you the right screen, am I? But oh well. So, here we are. That's my disclaimer. I suck. I know it. Don't flame me. Whatever. Okay, so what we need to do is I need to build a whole new screen. So we're using in the Arduino IDE, this is an ESP32. There is in fact a person out there, his name is Bodmer. I'm going to show you this. Where is it? There it is. GitHub.com. Now, where is he? Bodmer. Why did I not have the link to it? Where'd it go? Why did I lose it? That's just so weird. Anyways, here it is. This is where all the magic comes from for drawing this display with the ESP32 is Bodmer's TFT library. All of the wiring is handled. It'll be explained in the user file, the user setups. This is your file right here. So this is the actual driver that's allowing me to write this really elegant code that actually drives the screens and allows me to actually make these updates. Because the coolest thing you'll see is there's a lot of activity going on here, especially, you know, if we go look here, this has a nice 90-second graph, full 90-second graph, plus the updates, and you'll actually see that they're not always synced. But there's no flicker. It's not just that it's the way it's being recorded. There's actually no flicker. Now, I always work. This is the ESP32. You couldn't do this with an Arduino. You try to do this with an Arduino Uno. What was I going to do? So this is the last screen I was working on, and this screen actually does have some flicker. You'll notice that all of those green text updates are going bleh, 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 bleh. It's like a freaking heartbeat that I want to make me pull my hair out and I hit it with a hammer. So I've been working, this is my last goal, is to get rid of the flicker on those. So I was playing a bit with the way the sprites work, and haha, I just said the magic word. All of this stuff in Bodmer's library is only possible with these little sprites that he made. So instead of having to deal with a TFT, you just build yourself a little virtual TFT that's only this big, and you get yourself a handle to it. So you use the TFT sort of as just your canvas. And now you just make your own little widgets. You define them as a sprint or as a sprite, and each one of those becomes your little canvas. So a screen, like I have defined here, is really just a list of handles where each little handle points to one particular widget. And that's what I'm going to show you. The neat thing about this is these widgets live in two parts. First of all, there's a class, which is a .h and a .cpp file. And that pretty much defines all of the functions that are actually causing the updates and what sensors are going to be used and how they get used. And then, of course, there's an interface file. The interface is how we actually get from the display handler into the individual screen classes. If we go back to the code, here we are. In the code, in setup, if you're familiar with how any type of Arduino program works, you know this. It starts in setup. Okay, so we go ahead and we set a pin, set a bit of a heartbeat timers, whatever. Whoa, this is the cool bit. Oh my gosh. So I keep blurting about how cool this thing is with these two dual core 256 megahertz CPU, and the magic of it is right there. I'm actually creating a new task called my display task, and I'm pinning it to core 0. So your normal Arduino program, when it runs, you've got your setup, and then you've got your loop, and this is where your stuff runs. And you can see my loop actually has some stuff in it, as normal. But the beauty is we have a whole second core to use. So we use this little bit, and we say, okay, I'm going to create a whole new loop, and I'm going to call it this, and go run over there and run at basically the same priority, and you might have to figure out this number a little bit, whatever. It's some crashes. You'll understand what it means as soon as you find it. And whoa, look at that. This is the function. Let me scroll back up. Did you see that? The task code. This is the name of the function that I actually want to use. This is just some display text that will show up if you actually query it from the other thread, whatever. Some other numbers going on, but yeah, right there. That's the name of the function that I'm pinning to the other core. And there it is. And then at the end, I just do that. Basically, this actually never gets here. Except it actually never gets there at all. Instead, it just opens up my display handler, and then the display handler runs. That is in a bit of code off of our main, where are we here? Okay, sorry, catching back up to where I was. Software, ESP32. I just find it easier to show you what these classes and stuff actually look like, rather than trying to use this right hand or this left hand file tree system yet. We'll get to that in a minute. Anyways, when you get into HardSense, you've got HardSense.ino. This is what you're going to open. The data is actually where we have our fonts, and this is the actual text file that internally the ESP32 will actually be updating this. But by default, we just give it the actual keys that'll be in there, but keep it empty. Don't ever have this filled in on your computer. Those should always be empty. You don't ever want those escaping out to the wild. Bad. Anyways, some fonts. If we go into the source flow, we're going to see this little folder called Display Handler. Now this is my interface to Bodmer's TFT ESPI library, simply in this project, and how I'm actually using it to drive all of these particular screens. The TFT ESPI library gives you the actual underlying code to do this little bit of magic, but you actually need a higher level to actually handle it. So that's what this is. If we get in there, you're going to see these two files, display handler, CPP and H, and then underneath it is GUI. Don't click on that yet, because that is the folder of terror. Oh, yeah, look at that. There's a whole bunch of stuff going on in there. We'll deal with that in a second. Don't go that deep. Display handler. If we open this up and we look for that run command, that run function, where is it? Nope, I'm on the wrong one. Display handler. Where'd it go? Did I move it? There it is. It's supposed to be over here. And we look for run. There it is. Basically, this is loop on that other task, or on that other core. Remember that from here, we're pinning that task to the other core. So we have loop that is going to run on core 1, and then we have this, which runs on core 0. This is the core 0 loop function. This is where it's all going to happen. Why am I telling you about this? So I'm going to be adding that new Bluetooth screen, the Bluetooth configurator screen to my ESP32 project. Right now I've got all of these nice functional screens, but when I get into the configuration of it, for example, I go to when I need to update the settings, it'd be nice to just have an interface on the little thing down here, you know, giving me some information. So I'm just showing you how we're actually going to get to that. And we'll start writing some code there in a minute. I'm probably just going to, what time is it? Oh, well, it's already 45 minutes and I haven't really done crap. Oh, I suck at this. Nobody chatting over there? Nope. Okay, anyways, run. This is my loop. Int counter, we're going to do, and basically who? While true. Yeah, you ain't ever leaving that, right? So remember I was saying back here, in this task, there's this delay here. It never gets there. I just felt bad doing this. So I stuck a delay in there. What the hell? Why not, right? Anyways, it's running this while true. First thing it does is it actually checks to see if the display's been touched. And then it dispatches a command. We'll get to that in a lovely bit. And then it does this interesting thing about updating the screen on an interval, and then it just calls this random function called updating the screen on an interval. As long as it's not null, we call it. And then it goes to sleep for 20 seconds. 20 milliseconds. Now we can actually do some weird stuff there. If we actually just turn it back to yield, run at your own risk. So we don't need to worry about the touch yet, but we do have to go to the dispatch command. Let's go have a look at that. Basically, there's two things we can do with this class. We can either send it the command to load a new screen, or we can send it a command saying update a particular value on a screen. And that's what this dispatch command does. But the magic happens with this particular queue. Because you might have been wondering, okay, if we have these two things running on these two separate cores, they're running simultaneously, how do we actually get data back and forth? Well, that's where these queues come into play. And we actually put a mutex around them because we want to make sure that we're not stepping on each other's toes. And there's actually a yield going on. But we need to make sure these run as fast as possible. So we actually have two particular queues that we're using. One queue is called the display data queue. If you put a queue item into that queue, the display manager will pick that queue up. Will pick that data item up and do something with it. And it's either a command to change the screen or it's a command to update a value. There's a second queue called the output queue. And if you put a queue item into that queue, data in that the payload of that item will actually be sent out the Wi-Fi to the TCP server. So you can add all sorts of little commands in there, but that's something interesting that we're going to do later. What we're going to first of all do is we're going to actually add a new screen, and that's all in the magic of this load new screen. And we take advantage of something called function pointers. We're not having to worry about if statements or switch statements on every single type of update, except for here, where we actually make the decision, are we changing the screen? No, just do this then. So when we actually go through to change the screen, we actually unhook all of these function pointers from the one screen we were just using. We instantiate an object to a new screen, which I'll show you how to do in a second, and we take our function pointers and we connect them all back up to the new thing, and that's how we get a new screen And our display handler doesn't have to do anything. All we have to do is add these new screens. So why am I talking to you about all this? I gotta get organized. Here's why. The base display handler takes up this much memory and program space of the ESP32. Remember, we're not dealing with a lot of program spaces. This isn't like a hard drive in your computer. We only have this much. The display handler to actually do this adds this much of a chunk of program space. Adding every new screen actually only adds a very thin amount of program variables and memory to the runtime environment. It means you can actually have a lot of different screens without taking up a lot of space on your ESP32's memory and available flash. Let me show you what's going on here. I'm going to go to F1. I'm going to go to my board config, and I'll show you how I've got my ESP32 configured. A huge app. I'm not using OTA yet. That's actually something I'm going to be doing much later on, is I'm going to be reconfiguring this to have OTA. I didn't want to do that quite yet. A 1 megabyte SPIFFS, which is the file system, and then a 3 megabyte application space. If we actually look at our compiler of it, I'm going to close this. Go away. I'm going to go ahead and just build this. We click on here. This isn't VS Code. We go ahead and we click up here where it says verify, and then we watch the bottom. We look at the bottom there of our screen down here. It's going through preparing boards, verifying. You're going to see that we actually still have some available program space, and adding a new screen adds very little program space. We managed to do that with the display handler, so this gives us a lot of ability to add a whole variety of touchscreen capabilities, widgets. All of this is intended to be able to be flexible enough to display data from your computer onto this standalone wireless device. So I'm going to add a screen to it now. The other thing I want to do is I'm going to spend the next few days, and we're going to finish this project off, as I'm going to learn how to actually do this live streaming thing. Going to add a couple of last couple screens to this, and then we're going to build the circuit boards, which I've got some designs for. Actually, you know what? Let me show you some neat stuff that's coming up. In my GitHub repository, you're going to see this. This is the actual. Oh, this is P-board. Let me go to. What do I want to go to? HardSense. We'll open up the circuit board for HardSense that I've been working on. Bring it over here. We're going to go to Alt 3. No. So this is what the final circuit board is going to look like. I hope that's showing up okay. That is in fact the ESP32. You can see the big black thing in the middle. That is in fact the same unit that we have here. Some neat stuff going on. So this is KiCad. This is the software that I use for making the schematics of the circuit boards. Right, we got all this neat stuff. You're all familiar with writing code for Arduino for the ESP32s, which is what we're doing with this little thing down below. We're writing nice code, but we need to do other stuff, and we want to be able to connect it all together, so we're going to make our own circuit boards. And this is a very simple schematic for a circuit board that HardSense will be running on. This is the actual circuit board being made in, and I'll show you how easy this is to do. And then over here we have the actual final product of what it's going to look like. And what's really cool about this is I can actually export this into Fusion 360, which I use for 3D modeling of real-world objects, like this box over here, which we then 3D print in the real world. So how do we actually get all of this neat stuff moving around these tool chains and doing all that fun stuff? We're going to do that over the next few days as well. But in the meantime, we actually got to get to work and write some new screen, a new screen. I'm going to close this. Yeah, thank you. So all of that is available in the HardSense project in my GitHub. Now, if you don't mind, I'm going to get me some new water. Another drink. Go ahead, type something, ask me a question. There's a lurker out there somewhere. Go ahead, share the tweets, go around, let's see. What do we got? Okay. Oh, handle volume encoder. See, we just, that's a neat little thing. Check if our button is pressed. Display handler. So to add a new screen, I was talking about, every new screen actually comes from a single, whoops, I got to exit out of that. There we go. There it is. So now we got a bit of a grip on how the display handler is saving me all that work and allowing me to do the flicker-free updates. It all comes down to what's inside GUI. So each screen, so this is the home screen that we're looking at right now. And if you look inside here, you'll see two files called homescreen.cpp. And right below it is homescreen.h. Right there, those two lines. That is the class that defines how this home screen actually works. There is another file in here called home screen functions. It's right down here. This is the interface file from the display handler to the class. Now you remember I was talking about those function pointers earlier on. If we pop back over here, I was talking about this thing about how we just unhook these function pointers from one place and we hook them back up into another place. Well, that's what that interface file actually does. The interface file defines these standard function names and definitions. In this case, destroy, update, update on interval, create, there's a couple others, handle touch point. That interface file defines each one of these that we then use in a case statement here. That interface file, for example, where's my Bluetooth configurator? Functions. It actually defines the object that we're going to use as the screen. In this case, the Bluetooth pointer of this type, which is of course our class. And then we have a create function where we actually create our object and allocate it to that pointer. And then we have the destroy, which is where we of course destroy that object and free up our pointer. That's why we have the ability to handle all of these new screens, because remember I was saying we're only using this much of the available program space because of the display handler, and adding each new class or each new window only adds a slight little layer. It's because all of this already exists. All we're adding is the compiled code for this little bit, plus the compiled code that we have inside of one of these classes. It's very small. We're not adding any new libraries. We're not adding any new overhead or anything like that. This just lives right at the top of the little stack, and it just goes up and down as we change screens. And it just takes up very little program space when we actually do. So if we look back here at the bottom of it, we'll notice we're only Sketch uses, there we go, 101.3 megabytes, this entire bit. Now if we were to actually add the next new screen, we'll take a look. That's only going to go up like, 10 or 15, 20, 10K or whatever. It's very small. Still nobody's chatting. Anyways, let's have a look. We're going to add our new Bluetooth configurator screen. So display handler. If we go back up into our global definitions, we have our screen types enum. So I've already got my Bluetooth configurator defined, my connect to network, my home screen, my game screen, my CPU detail screen. So let's say I wanted to add a new screen called, I don't know. I guess that's hard to actually, it's like a 30-second delay. So let's say if I was going to add a new screen called, I don't know, a hard drive. Oh yeah, I got to add my hard drives. So HD1. So that's now a new screen type. I could add it. The next thing I would do is I would kind of go into here, display handler, GUI, and I would add 3 new files. What was that calling it? HD1 .cpp, HD1.h, and the HD functions file. In this case, I've got my Bluetooth that I'm going to do it to. Where are we? So the case statement is on that enum. So after you've added a new item to the enum, I'm just going to add it in as a Bluetooth configurator screen. I have a serial.print line here because, well, I like to debug things the old-fashioned way. This goes right to the serial inside the bottom down here and allows me to do, ESP32 stuff. Okay, so where's my Bluetooth? So far we're actually hooked up the destroy screen, the update screen, in the create screen. Basically, any new screen I need to create has to have those three functions at a minimum. Without those three, you just can't really do anything. So, up here, if we have a look at where it is, functions, here's my create Bluetooth, destroy it, and my update. All they do is they just sort of wrapper functions for the actual class. That's why it's called an interface. It gives the function pointer from the display handler a place to point to, and then it just does this tiny little bit. And every single class basically does this exact same thing, except it does it on its own local object. So if I open up my home screen, where's my home screen functions? Home screen functions. You'll see it does the exact same thing. Create, destroy, update on an interval, and it's just a wrapper for the actual underlying class's function. You can't have that generic function pointer in the display handler latch directly onto the object, because it just complains like you wouldn't believe and kicks you in the nads a few times as you try to wedge it in there, and it's never going to freaking happen, so don't even try it. Okay. Right. So instead, we need to have them wrapped into a generic function that we can actually point our little function pointers to. And if we look at the display handler.h, they're just right there. Void, update current screen, on interval, destroy, handle as touch point, and that's it. It just points to our little object. So off we go. Our Bluetooth configurator functions. Create. All right, let's go create a new screen. And we don't need that one. We do need that one. Game screen. Goodbye. CPU screen. I gotta close some of these. I don't even know why they're open. So our .h and our .cpp file. This is our class. This is actually how we're going to instantiate our screen. In this case, what we're looking at is this is my game screen. I call it my game screen because the top right, that RAM, that's actually my video card's RAM, not my system RAM. That's my video game RAM. The network is still, my little network. The FPS is my own frame rate counter. You can actually see how that's built if you look in the other Windows project. The CPU. So this is sort of all the information I want when I'm playing a video game. All available right there. But I want a Bluetooth screen. So the class I make just simply is include the screen base. See, I cheat. Most of the work is already done for you in that screen base. Don't even look at it. Right here. It has, this thing will load this actually takes care of loading the fonts. It adds my little button. It handles my touch if there's some default stuff I want to do. It takes care of drawing some nice gives me some little border functions that if I want to use them. Basically, the screen base does all of the work. Here's the H file for that. But our class just extends it. So each class inherits all of this wonderful functionality without creating any new stuff. It already exists. Remember, those function pointers are just changing where it's actually happening. So we don't take much space in our stack, and we can just keep adding screens and adding new screens, and it's really a wonderful way to get this done. And here's a neat little trick with the get sensor list, which I'll show you later. Okay, so we are on the Bluetooth configuration screen. So our constructor, create, this is where we're actually creating our base screen. So let's see what we're going to do here. I'm going to have it fill up in red. Set the cursor somewhere, and I'm just going to pop up some text. Okay, fine. So this is just me building my template out just so that I can actually have this screen pop up. And then we have this update value. No, so this is just sort of a template. I'm not actually using it, but it's going to get called anyways. You need to have it there. So this is just the default skeleton code. And then, of course, get sensor list. This screen doesn't use the sensor list yet because I haven't figured out what we're going to do there yet. And what else? That's the destructor. Doesn't really do anything because we haven't created anything. If we look at our H file, we don't have any variables or anything going on, so our destructor is pretty much empty. Okay, so well, let's see if this works. Well, first of all, we got to somehow make a call to this. So I want to create this screen. If we go back to HardSense INO, our top level file, our main program, in our loop, we have the very top of the loop, we're actually looking at this. Are we connected to something? We have this HS serial object. And if we go all the way to the top, you'll see this is being instantiated from these two little files. Let me close this up. At our top level, we have the display handler, the file system, and HS serial. I always find it easier to look at it in here. So we have HardSense. In our source directory, we have our display handler, we have our file system handler, and we have our serial object handler. This is where we either do the Wi-Fi connection back and forth, or we do the Bluetooth connection back and forth. It separates our our GUI from the workload. So you're starting to see what's happening. The display handler runs on one core, and our serial object, which is handling all of this connection to the TCP server and all this other stuff, is running on the other core simultaneously. The ESP32 is a wonderful piece of kit, and it's allowing us to get away with all of that really fantastically. So I want to create this new screen for our Bluetooth called the Bluetooth configurator. So obviously I need my serial object to be able to somehow be aware of this screen. So what are we going to do? If we look at our serial object, it's just made up of a CPP, an H, and an interface file. I do that a lot, don't I, these interface files. So we go back to our loop. Where's our loop? So are we connected to something? Connected to something means, are we connected to either Wi-Fi or are we connected to Bluetooth? I don't know. Are we connected to something? If we are not connected to something, then we do this. But if we are connected to something, well, then we just do that. And then we do some other stuff. One of the refactorings I'm going to be doing over the next couple of days is getting rid of this and making this a lot cleaner. Trust me. Anyways, if we're not connected to something, means we're not connected to Wi-Fi or we're not connected to Bluetooth, something, either it's just starting or we lost our connection or whatever. First is we check to see if this button is pressed. Is the BT button pressed? That's the blue button. If we have a look down below, the blue button here on my project, that's my Bluetooth button. So when it starts up, if you're holding the button down and start the give it power, hit the reset button, it'll power up into Bluetooth mode. And that's what we're doing here. So it's going to do a serial.print, so I'll plug the cable in here, starting Bluetooth, and then we're going to handle the Bluetooth connection. So if we go to our serial object, handle our Bluetooth connection, looking on the bottom left corner for my handle Bluetooth connection function, there it is. And you can see I've actually sort of have this in there and commented out. I actually just finished doing some refactoring on the way this works, and it works a lot better now. So what I need to do is actually figure out where I can steal one of those functions from. They are, if I go back to my home screen, yeah, handle touch, yeah, add item to the display queue. So all of this is a touch screen if you haven't figured that out. So I'm going to go steal this bit of text right here, add item to the display queue. And where was it? So I go back to my Bluetooth functions, to my constructor. I'm going to print my Bluetooth, and then I'm going to do that. But I actually want to call my Bluetooth. There it is. So our serial object is able to put items into this display queue. This function actually handles our mutex locking around the actual variable itself. It's actually, I think, a list of a particular structure that I created. But it can only ever be handled by one or two particular functions, one that adds it and one that removes it. So that mutex is always locking, and you're giving yourself some thread safe protections between these two cores accessing these two particular variables. This way you don't crash. You have to have protection around them. So we're going to actually add a new item to it. Now this item is actually just a key and a value. I don't want to have to mess around with creating data structures or creating any chunk of memory more than I have to. It's bad enough that I'm actually using a string as the value, because that dynamic of the string can actually catch us off. But it's not a horrible deal at this level. But if you want to know more about that, ask me about it, why strings are always a bad thing to use. But I'm cheating. Because the ESP32 has so much space, I mean, oh my god, it has so much space. You can actually get lazy like that. Okay, so we need to add an item. So this is our Bluetooth constructor. So when we create this Bluetooth string, I'm just going to print this out for some debugging purposes. We're going to fill our screen, make it red. We're going to set our cursor somewhere, 4040, and we're going to type that text onto the screen. Yeah, I don't want that there. I want this in the serial object. Why didn't you say that? So I come back to my serial object. I was changing this, and I want to put this here. So the very first thing it does, the serial object, yeah, this makes more sense to you, doesn't it? Is I'm going to give it the command to change the screen to this, the Bluetooth configurator. Now, this is where the serial object actually goes ahead and creates our Bluetooth serial object. Again, we're using function pointers between our Wi-Fi handle and our Bluetooth handle. That way our handle input functions don't have to worry about what it's actually connecting to. We just change our function pointers. It makes life so much easier. It does its thing. So when the Bluetooth function is run, the handle Bluetooth connection, the first thing it does is it should update the screen to our Bluetooth configurator, which is just red and text. So all I need to do is update this code. So I go back to HardSense INO. Now if we have a look, what's going to happen on the screen, if you've never seen this before, on the bottom of the main window is this. I'm going to clear that. Make sure that scrolling is on. For some stupid reason, VS Code always turns this off. I don't like VS Code. So we're going to upload this. The compiler was going to put a whole bunch of information here. We'll probably have to push a button over there, and then hopefully we'll get into the Bluetooth configurator. So at the very bottom of the screen, you can see where it's going to verify. Now it just takes a while to compile. This is so much slower than Visual Micro to compile this code. Oh. So I really want to have a Visual Micro license again. It's about 25 bucks or something Canadian though. But you know what, I actually think it's worth it. I just can't afford it. So I do have a Patreon account. You can see at the bottom there's a PayPal me and a Patreon account. You know, once I can manage to get up to 25 bucks, I want to buy a Visual Micro license and go back to having fun with that. But it's not really a priority. I actually want to get some better cameras. But you know, doing this through VS Code is so freaking slow. Look at it. It's just still Visual Micro is just so much faster. Does it almost sound like I'm begging for a fin? Come on, come on, come on. Compile already. Oh my gosh. Hurry up. See, this is actually kind of a real turnoff of how slow it is. Oh, what the hell happened? It crashed. Oh, you know what? I got to plug it in. I got to plug this damn thing in. That way. That's only part of the problem. It still is slow. I wasn't complaining for nothing. There. Okay. So, yeah. So that's all plugged in. You can see at the top right corner here from the ESP. I just plugged in the USB cable. So now that's on serial port 6 on my computer. Now let's do that again, and it's going to have to go through the whole. Pardon me, I'm so rude. It's going to have to go through that whole damn verify and compile again, and it's going to take so damn long and it's so slow, and it does this, which pisses me off. Serial. Every time you compile and upload, it does this request out on the internet, which bugs me. Doesn't have to do that. Connecting to the internet randomly like that for no apparent reason. And then it just keeps, you know, we're waiting. I should have the right screen, so, yeah, sorry about that. I was having the wrong screen being displayed. It's because I suck. So still compiling the code. You can see at the bottom of the screen, it just did that hard lookup. So yeah, that's because I've got the USB plugged in now. But it's still taking forever to actually compile. Nothing changed. I do have a build directory configured for it. Should be using it. Isn't it using it? Oh, there we go. We got action happening. Yes. So let's do it. You gotta press and hold the button. Visual Micro does a much better job of being able to reconnect without making you press the damn button every time. And also with Visual Micro, this auto scroll on always stays on, whereas with VS Code, the auto scroll, for some reason, turns itself off for a ridiculously amount of times. Okay, so that worked, right? Yeah. So we just added the Bluetooth configurator screen. What's my new compile size? Backpacking, where are we here? There it is. 138, 1254. Did it change? Anyways, I'm going to reboot it by holding the Bluetooth button down, and it should go to a red screen and say Bluetooth configurator. If not, I'm an ass. Whatcha! Damn, it's almost like I know what I'm doing. What do we got going on here? Okay, so we got the base of the Bluetooth configurator screen going on. Wait, I was looking for something for you, wasn't I? I don't know. Okay, now the next thing is to actually get some data being displayed on the screen and making it look pretty. So what do I want to do with this? So the data that I want on the screen is this. I'm going to pull up HardSense64. There it is. Settings, Bluetooth configurator. I wanted to display the time. So I want to put my time widget onto this Bluetooth configurator screen that you're seeing below. It's just red with the black text. I want to put my time box on there because, you know, if I do the update time, as you noticed maybe earlier in the stream, like forever ago, I did something wrong. And then of course I want to have those values displayed. In fact, if we just connect, there. I also want to have this, if you look below, I should have the state of this saying, is it connected? And what's it connected as? Because, neat thing, this is another variable I actually wanted to add. So check this out. It's connected to Bluetooth. Where can I do that? Bluetooth and other device settings. Where are you there, little bad boy? There it is. Oh, I gotta change the name of it. If I look at my computer, it's connected as HardSenseESP1 as a Bluetooth device. And that's configured inside serial, but it's actually just a hard-coded string right now. If I go to my handle Bluetooth connection, you can see here, BT serial begin HardSense1. I actually want to put this as a variable inside our configuration file. So that'll be a new option to add here, but that's a later one. Right now I just want to get this Bluetooth configurator screen working. So we got to get some of this, all of this data displayed here, sort of like this. Password should always be empty. And I think there's a bug on this screen too. So yeah, we basically want to make this screen stop looking ugly and take the next step of adding some data to it. So let's see here. Okay, what are we doing here? So let's exit out of here. Get that. I'm just going to give it a reboot. So I want a time widget. I want my time widget. Right? I mentioned the time widget. So I need a new theme. You know what? First of all, I'm going to start with a theme. What's my theme? So I'm going to go ahead and open up my game screen, H file, and you'll notice that there's a whole bunch of stuff that I built into this file. The first thing is my theme. And that's defined by these particular variables right here. So I go back to my Bluetooth configurator screen, the H file, and right at the very top, I'm going to start to define my theme. I need a few variables as well. Game screen. There's a theme object I need. I need my H file. It's private, but I'm going to call this, what am I calling this? Bluetooth configurator screen. BT screen. Bluetooth configurators. You know, I'm all for naming variables clearly and concisely. So, yeah, let's not take a shortcut. Let's actually call it BLUE, B-L-U-E, Bluetooth configurator. You do what you do you, I do me. Okay, so there's my theme. Now over here in the, I want to close out when I want my game screen. No, not that one. So I just take one of the ones that I've already built, and I'm just reusing it. What was I looking for? Game screen. What was I looking for? The crate. Where's my constructor? Okay. So yeah. So there's basically where I'm setting up my theme. So Bluetooth configurator. What's that? Man, things move around on this where they're not supposed to go. So let's see here. Game screen. Yeah. Just going to paste that stuff right at the top, and then rename it. There. Now, this should be a blue theme, so I can actually, if I wanted to, I can just come back here. Somewhere I'm doing this. Yeah, I got to set my sprite. Got to do the load. Yeah, I think I'm already doing that, right? I want to set my font size and fill the screen with black. Oh, just as a filler. Set my text colors. Unload any basic fonts. Why am I reloading that font? Oh, that's the text printer sprite. Oh, this is my shortcut sprite. That does a pretty cool thing. Now, this thing actually does some neat things. Let's check this out here. Draw, time panel. No, home screen. Whoops, home screen. Where's my time panel? Draw a time panel. Go to my shortcut. Where is it? Right there. So I'm just going to steal this. Well, that's a crazy ass function. Go back to my Bluetooth configurator screen. I'm going to paste these in here somewhere down here. I'm going to rename them. I'll refactor this once I get this figured out what I actually want to do. Right now I'm just throwing something in to actually get a theme going. That's all I'm really interested in. I know my time panel is going to be in here, but what I want is a theme. So the screen that you're seeing right now is a particular blue theme. You can see that this is sort of a blue theme. But if I pop into my GPU screen, or my game screen, this is actually using a grayish theme. Now my Bluetooth configurator screen, I actually want to use a red theme. That's because I want to know that this thing, if I'm over there, and I look over and I see this red screen, I know that my Bluetooth configurator screen is on. So I also know I'm going to be using my time panel there, so I'm just stealing those functions for now. Because I'm reusing these, I'm probably going to end up building a standalone widget for it later on, but for now, let's just cheat. Home screen H. I need, there was a couple of function prototypes I needed. Where were they? Draw time panel, draw update panel. I got to drop them into my H. Are they public? No, they're private. Let's dump them in there. Save that. Pop over to the configurator. Save that. Time panel X. There's some interesting variables going on there. That's the placement variables. You can see these. We got CPU panel, GPU panel, and that. Each one of these defines the coordinates for each of these widgets that you see displayed on this. Oh my God, I am so sorry about that. I've been talking to you and looking at the wrong way. All of these defines, I'm looking at the home screen right now, the same thing you're looking at in this right below me. Each of these defines the coordinates of one of those little widgets. So the net panel, the CPU panel. Eventually, in a later iteration, this definition will actually move to a file that will live on the SPIFFS file system, and we can actually create a neat little interface that will allow me to upload new screens through the Bluetooth configurator instead of through code. So that's cool. But that's an iteration later on. Okay, so I need a time panel. Where am I looking for the time panel? So I'm just going to copy those over to my Bluetooth configurator screen. Up there, my time panel. So that should calm down a whole bunch of those errors. And there we go. Home screen, no, Bluetooth configurator screen. We're going to pass our theme around to some of these functions and whatnot. So we're just going to go through and fix those up. Text printer sprite, you can see this is where we're reusing that one little widget just to do a whole bunch of work for us. Home screen, nope. Home screen, nope. There, I think we did it. Why is this all red and gnarly? Let's go have a look at our home screen. Dial screen, RTC lib. That would be why. Our Bluetooth configurator needs access to the actual time base. Wait, that's the wrong file. Bluetooth configurator. Home screen. Okay, let's see. I think that should do it. We should now have our blue themed time on here. On the Bluetooth screen. Right? Yep, that should work. Okay, so we got to go back to our INO, hit our upload file. I'm going to clear. Why is auto scrolling off again? Got to turn the damn thing on. Okay. Hit our upload. Now it's going to take forever to do this little compiling thing. So now, my goal is to actually get a theme going here. So I'm going to go back to a website and show you something really neat. Where is it? Where is it? Hobbies, ESP32. There it is. There's this neat little, now Bodmer's TFT ESP, the library that I'm using to actually drive this whole display update, uses 16-bit colors. So, if we go back to that code, on my, is it done yet? No. Oh, something's not right. RTC was not declared. Home screen. I forgot to create my real-time clock object. So I need to put that there. Oh. See, this is why Visual Micro is so much better. You make a stupid little mistake, you recompile, it doesn't take so long. And why is auto scrolling turned off again? Gotta go back to my INI file. Gotta go here. See, Visual Micro sounds like an advertisement for Visual Micro. In Visual Micro, you don't have to go back to the INI file to compile. Doesn't matter where you are in your tree, what file you got pulled up. You could be anywhere, not. Hit F5, off you go. Here, no, got to go back to your INO file so that your damn icons appear. $25 for a license for a year. Okay, hurry up and build the compile. I want to see what my blue-themed Bluetooth configurator screen looks like before I make it red. Come on now. So I got to push a button. That's the other thing Visual Micro is better at. Remembering that I don't have to push this button. Visual Code makes me push this button like every time. Well, actually not one time. It surprised me. I was reaching for it and it started going. It was like, yes. But the next time, no. Hey, we're moving. Okay, so now we've got to go push the button. You suck. Yeah, it's still going. Chugging away, push the button. There we go. Now it's uploading. Oh, now, once it gets near 100%, I'm just going to push the button. And then when the ESP reloads after being uploaded, it'll just kick right into Bluetooth mode. And we should see our my time panel show up in the top right corner, the same place it is on the home screen. Or not. Okay, well, let's turn on the serial monitor. Okay, now we'll push the button and then we'll reboot it. What happened there? Start 1, start 2, Bluetooth configurator screen. What the hell is, just some starting Bluetooth. Yeah, dispatch command. Oh, yeah, that's some stray code I left in here. Yeah, I was just debugging. So I actually just did some refactoring before this. I'm using branch 13 of my GitHub repository. One of the big changes I made is the way I'm passing in the proper enum values now and saving a little bit of memory and just doing things a little bit cleaner. So I just got to remove some of these statements. So that gets rid of that. Dispatching command. Where is dispatch? It's the old-fashioned way of debugging, right? Just serial.println. And you can see I had some of the original commands still in there that I can comment out now. Yep. Okay, good. Where was I? Top of the switch. Yeah, I got rid of that code. Start 1. So I'm in my Bluetooth configurator screen. Oh, that's what I didn't do. I didn't actually make a call to draw it. So if I go back to my game screen, no, my home screen. Yeah, this one. I'm going to get rid of my game screen. It's taking up room. Okay, so back up to the constructor. Where do we have it there? Draw a time panel. Pop over to my constructor and my Bluetooth configurator. You usually want to do all of these last. You set up all your variables, you do all of this work, you create all of this stuff in memory, and then wham, you hit it with a draw. Like that. That's just how you kind of get rid of the flicker. So when you're dealing with these libraries, and even the slower libraries, you do this. You like put as much junk as you can into memory, you just fill it up. And you've got this text printer sprite here. So you look at the home screen of this thing, there is like 5 or 6 sprites, which are just individual screens. There might actually be more. So I'm taking advantage of all of the memory. Now, what's really cool about an ESP32 is there is an available SPI-controlled 8 megabyte PS RAM add-on. And if you do that, you can have like infinite screens and interactivity with a huge amount of memory because you load it all up. And you can do this with just these little tricks. It's not hard. Draw the time panel. That should do it. I should now have, oh, I need an updater. So update screen. Update on an interval. Yeah. So this is where I actually need that update screen on an interval. Here I actually check the interval to see what's going on. And this actually makes a lot of sense for the Bluetooth configurator screen. So I am just going to take the, I don't even think I have an update on interval in my Bluetooth configurator screen. I got my sensor lists. There's my destructor. There's my update screen. There's my update on interval screen. Let's just get rid of some of that space. Let's rename it. Okay, now we needed a couple of variables. Last time updated. Yeah, these go into the H. Under that. Well, like that, I could have just copied that whole little bit. So obviously I'm using this twice. So once I get this working, I'm just going to create a widget that does this. And in that widget, all you do is you just pass it in your theme and your coordinates. And there's actually a coordinate object. And boom, there's your widget. So anything I'm going to use more than once in any shape or way, you should always create a widget and then just reuse that as a pointer. That way you're saving a lot of memory and program space. Remember, this isn't a Windows application you're baking here. You can't just, there is no garbage collection. There is no, tidying services to come along and sweep up after you. Oh, look, you left some memory hanging here. No, that doesn't work in this world. You do that yourself, otherwise you're going to be seeing brownouts and repeats, and you're going to be going, why is that going around in circles and rebooting in a loop, and oh. So yeah. Okay, where was I? I guess I need to have that actual function defined, don't I? Update screen on interval. That should go into my header file. Now is a little bit trickery, because now I have to go back to my interface file and define an interface between the display handler and my newly created update on interval. Because you can see here I've only got my create, my destroy, and my update. Now I need an update on interval. So I'm using my home screen as my example, as my skeleton. So where's my home screen functions? It's in the wrong damn place. Move it over there. Pardon me. Where am I? Display queue, no. Touch, no. Sensor list, no. Upscreen on interval. So I'm just going to steal that and put it into my Bluetooth interface file. Update. What naming configuration am I using here? Bluetooth configurator. So I'm not always consistent. Obviously I've got some underscores there where I don't up there, but whatever. Now I need to point it back to my actual object. What am I doing here? Update on interval. Update screen on interval. And then in here, where's my, why are you over there? Update screen on interval. Check my time. Yes, update the time. So that should be working. I have a draw time panel. Oh, I need to do an update time on here, don't I? Draw time panel, update time. Whoops. Get rid of that. Save it. Should be good to go. Go back to the ESP32. Boom. Now, I don't know. You may have noticed I just added this entire screen, added some functionality, put in a little widget there to display the time. I've got my theme set up. I did all this. This is all cut and paste code. I haven't even started writing any code yet. This is for the display handler on this microcontroller that's running on Wi-Fi. That's how easy it is to work with this sort of stuff. Why do I have this queue object? Oh, that's my splash screen. That's something, a new screen I was going to be building later on. Anyways, waiting for the verify process. Take your time there, IDE, Visual VS Code using version, Arduino. Oh my god, it's so slow. I lost my viewer. Okay, so did it, I'm just going to see if it's going to connect by itself. I'm just going to let it go. If it doesn't connect by the second time, it's probably not going to connect. Is that the theory? Yeah, see, I got to go push the damn button again. VS Code doesn't make me push the damn button. Or sorry, Visual Studio, Visual Micro. But I guess probably more people actually use VS Code. So, but you know what, switching between making this a VS Code or a Visual Studio Visual Micro project is trivial. I mean, okay, what happened here? Is it rebooting? Oh, I forgot to push my button. There's my blue theme and okay, that's not right. Well, that's not right at all. That's right. Huh. Okay, so let's think about this. First of all, let's just check the interface file. Yeah, update home screen and interval. Bluetooth. Oh! Oh! Okay, well I know one problem. I didn't actually hook that up in the display handler. So I got to go to my display handler. Where's my Bluetooth configurator screen? So there is an update screen on interval that I need to hook up. And I need to point it to the update, which I need to point it to that. Okay, so that will take care of that. Update screen on interval, yeah, update the Bluetooth configurator on interval. So now my function pointer, my interval function pointer is actually pointing to the right function. I forgot to connect that. And that's all I have to do, because there's a function up here that automatically unhooks everything. So, okay, right, so now I've got the update on interval working. What else do I need to do? Did I do some? Oh! Okay, I think I'm sucking up some improper memory usage there, Betty. Better fix that. I'm going to go ahead and close my, yeah, I don't need the serial objects open anymore. What's in the destructor here? I just wanted to have a look at the destructor and see if I'm missing something. Yeah, there's nothing special about the time panel. So no worries there. I got the load widgets for CPU, the net panel, the mem panel. The time panel is not a memory hug. That's good. I just need to hook into it correctly, which I didn't. So I've got those functions, right? Yeah. Those are in the header file. Yeah. And then in here, what am I doing here? Oh, where the hell is those coming from? Where is that? That's in global defs, yeah. So that's not an issue. Oh, is it an issue? It's an issue. No, wait. It should be in screen base. I shouldn't have to worry stuff about like that. Yeah, see, global definitions. Yeah, I don't want to have to worry about stuff like that. That's why I bury stuff like that in the base. So that's fine. Text printer. Okay, I'm doing something wrong with my text printer. Did I set a... Yeah, this. Why am I doing that? Huh? Why am I doing that? Maybe that's the wrong bit. Yeah, see, I'm not doing any weird stuff here. Just doing the fill screen. I got my... oh, yeah, I didn't actually prime the text. So this text printer, this is actually part of my base object. It's there to do all the heavy lifting for any generic stuff I want to do that isn't really necessary for an entire widget. So yeah. Where am I? I'm going to just get rid of that because I don't need to do stuff like that yet. Setting the text color, yeah. Oh, why am I loading fonts here? I was doing something different there, so there, let's not mess with any fonts. Good, right? Fill the screen? Oh, I should do fill the screen after. There we go. Because you know why? This is setting memory. Damn, that scares the hell out of me. What the hell? The reason why is this is setting memory. This is actually doing activity on the display. So remember I was saying, stuff your memory first. Holy cow. I was so far into this that I just got like, it scared the hell out of me. I was just, okay, what am I doing here? Text printer sprite, fill screen, draw time panel. Yeah, that's right? Text printer sprite. Yeah. Oh, see, I am actually loading a font there. Better load a font. Load the fonts. All right, home screen, CPU, don't need that, don't need that, don't need that. All right. Ah. You know, thanks for your help there, guys. I'm going to point it out that I haven't actually started my connection. Okay. I do believe we're gold now. Let's go back here, push the button, and wait. While I'm waiting, you guys have fun staring at this compile. I'm going to go fill up my grape juice. So I've been thinking about ripping out the display handler into a standalone library with some instructions on how to add screens. Wouldn't be that hard. But it would unload a lot of work from each individual project that I have to build or that somebody needs to build. It gives you the capability of having a touchscreen display manager without the low-level work-ish. Well, that's not true. Wait till you see what I do next. You'll think twice. Okay. Yeah, I gotta go push the button. Damn. I really wish it would just work. You know what, next time I'm just gonna wait. It'll eventually time out. But maybe it just takes longer. Okay, okay. Let's push the button. There's a lot of button pushing in this. Opening the serial port, what's going on there? And we're golden. Yay! Now is a good time to, okay, oh, we have one more step that we want to do, don't we? We got to pick a theme. I want a red theme. So basically the way my theme works, where's my header file? I should have written this down. Okay, so I'm going to reboot this. No, actually, you know what? I can do that. So the background color is the second darkest. So what do I want? I want red. Let's put that in there. I'm on my Bluetooth configurator screen. I want my panel background color here. I'm going to put that number in there. That's this red. Now, if we actually if we zoom in on this and have a good look at that, it's hard to see, but there is in fact a drop shadow on these box. That's why the home screen actually looks so good, is because I tried to do my best by adding some decent GUI elements in here. So there is a drop shadow there, and you can see it right here, the box drop shadow. So that's going to be a darker color. Let's go. Let's try that. We can always adjust it later. That's the box shadow. Okay, the text color is fairly light, so let's go over there for text color. Now the overall border color of the oh, sorry, you're not seeing what I'm seeing. My bad. So I'm actually just taking some values from this color picker and pasting them into my text color, my background, drop shadow, my border. Now I'm looking at the header color. So if we go back to the header color is not displayed on this particular screen. So let's go have a look at where we can see a header. So that's the header color. You can see where it says CPU over here and GPU. That's the header color. So that's basically between the background and the drop shadow. So let's go find a good place for that. We'll go for there. That's the header color. We got the background, and then we need the border color, which is actually a bit lighter too. Well, we can make adjustments to this in a minute. But what you're going to see, the border color, yeah. So now we have a red theme. So I'm going to go ahead and push the button. put this back into Bluetooth configurator mode. And you can see we've got my blue theme. It doesn't really show up well on these cameras, but that's actually a blue theme. Now I'm going to go ahead and upload the new bits. Okay, so the new code is uploading ever so slowly. Hey, I got a new Twitter follower, ESP32 net followed me. Woohoo, hey guys, welcome. Guess I'll follow you back. Cool. Nice. What else we got going on here? Cool. Hey, retweet me if you want, man. Alright, what's going on? Still no chats. What are we doing? Oh yeah, I wasn't going to push the button this time once we ever get to the point where it actually finishes compiling again. Oh my god, it's going to take me forever to finish compiling this damn thing. Now, just for the sake of merriment, I'm not going to push the button. I'm going to just see. If we look at the very bottom of the screen, you can see where it says connecting. And then if you look right below me, you can see it's actually doing its thing. But yeah, it's not. I gotta go push the button. There, I pushed the button. Now it's actually uploading. So annoying. Okay, so that is now uploaded, and we've jumped into the home. Oh, I have a stretcher. Okay, what are we doing here? Let's go back to the NVIDIA tablet. Okay, Bluetooth mode, red theme. I wanted to try and set up a red theme. There's my red theme. That's how easy it is to use this display manager I built. So now, I need some more information on here. Now things get a bit tricky. Okay, now things get a bit more tricky. For this particular screen, I want to display data that's actually stored from a text file in the SPIFFS data file system. If we go back and look at HardSense software ESP HardSense. So this is the root level of the HardSenseESP project. There's our INO file. This is an ESP32 project, which means if we have a data folder, inside that folder, any stuff that's in here can actually be uploaded onto a file. Sorry, you weren't looking where I was looking. Sucks. Anyways, in my HardSense ESP data on GitHub or in the project folder, this is an ESP32 project. So you have your data folder, and inside your data folder, anything that's in here can be uploaded to a file system on this ridiculous little microcontroller. Dual core, 256 megahertz, Wi-Fi, Bluetooth, and a file system built in. You don't have to do anything special. Well, one thing. File system. So what I need to do is I actually need to read these values and display them happily on here. Okay, so what I'm going to... So I'm actually going to... No. Here's a question. Here's a question. What do you do in this situation, developers? I don't know if there's anybody watching this. Nobody's commenting. Hopefully there's some developers watching you. Here's a question. This is about the world of technical debt, I guess. This is a tech debt question? I'm not sure. It depends on if this is what sort of development I get. See, here's what I'm wondering now. Do I spend the time at this particular moment to clean this up and take do I take these time functions and this time widget, because I'm using them now on this Bluetooth screen and the home screen, I'm actually reusing the code. I most certainly don't want to do that. So now is the opportunity for me to create either a widget or a panel. In this case, I want a widget. A panel will contain widgets, but a panel just sort of organizes things, and it can become a sprite. Whereas a widget actually has your update, where you actually need the changing values. You break stuff down like this. This sounds like it might be a little bit weird the way it's broken down like this. The reason why is to separate as much as possible. The reason why it's broken down this way is to separate as much as possible, like every iota of every cycle on that 256 megahertz of the dual core, every cycle, stuff as much as you can in memory, and then drop your draws. Do the drawing methods on the actual display. That's how you're going to get rid of your flicker. So that's what I do by trying to be really specific with these update functions. The other part of that is you redraw the absolute smallest amount of space that you need to do. That's why you're stuffing so much stuff into memory. If you actually have a look at the home screen of HardSense, let me reboot it. This screen is actually updating very fast. But at any given update, at any particular refresh, only tiny little bits of that screen are actually being redrawn. Sorry, I'm just going to get a pointer. I forgot my pointer. Here it is. I'm back. So the main reason for stuffing all this stuff, all of this data into those memory sprites and whatnot, on every refresh, on every one of those update on intervals, only a very small amount of this panel actually gets updated. In this case, only that little bit where it's actually those 3 digits. Only where those 3 digits. The W never gets redrawn, the C never gets redrawn. This outer ring only ever gets redrawn when it changes color. So the only thing that's actually being redrawn here is the inside dial. The rest of this, like these headers, never get redrawn. This only ever gets redrawn every second, but again, I think that's actually specific enough not to do the whole thing. But you know what I'm saying. So every refresh is only ever updating that tiny little bit. That's why we don't see flicker, and that's why it happens so fast. Okay. Now, my question that started this whole damn sidetrack was this. Wow. Do I want to take the time? Oh my God. I would have just done it instead of talking about doing it. It would be done. As a developer, if you're in your development environment writing code for your boss, do you take the time right now to parse this out into its own little widget, or do you just plow ahead, finish off your screen, and then come back and refactor it in parts like this? I don't know. I'm going to... See, if I do it, I have to rewrite that other screen as well, so I'm not going to do it. I'm going to do it later. I want to just plow ahead with this for now. Okay, what else do I want to do? And I'm not even going to change this location. I'm just going to leave it up there for now, but I'm going to leave it as red. Now, as I was saying, I want to get all that data that's stored in this file and display it here. So, I'm going to have a little widget or a little panel just in this class. I'm not going to create a whole new subclass like one of these. I'm actually just going to create a little function that'll handle that, updating that little bit, and it's going to be for each one of these particular lines. So the first one I want is, go to my header file. I need a new function called, what do I want to call it? Oh, draw, sorry, I'm bouncing around here, SSID. SSID panel. Okay, good enough. Let's go over to our class file, pop down to the bottom, paste that, put a couple of braces in, go back up here, get that, drop to the bottom, put that there, paste it in. There, now I got my damn class. They're always void. Everything should always be void for the most part. Okay, so I'm going to, we have a draw panel up here. I'm just going to steal it. There. Loader the font, a draw box, and a drop shadow, but I want to move this. I don't want to do it there. So I need a couple of new coordinates. And I need to call this, what am I doing? SSID. 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 And I am going to put this at the top left for the hell of it. It's a good place to start, right? Why not? Put it there. Okay, so loaded a font. Why 18 point? Yeah, hell with it. I got to change those coordinates to my SSID panel. And my Y. What the hell is this? Oh, this is a width and a... Yeah, so that's a width and a height. I don't know, 20? Oh, no, width. Let's go with 50 for now. Let's go with 20. So this is going to be drawing me a box. It does all of that work. I don't have to do anything. And I'm passing in my theme. And then I'm going to want to put some text on there. So let's just go to our home screen, find one of these little functions like the net panel. Oh, no, not the net panel. That's a bad example. HDD panel? Yeah, that'll work. Let's just pick one of these that's going to do some work, that's going to do something for us. Oh, you know what? That's another option, is that look. But for now, let's just go with... So now I'm trying to decide, do I want to have... There. So many decisions. Okay, let's just go with this one first of all. No, not that one. You know, the easiest way to figure this out is just to go have a look at the home screen and decide what look I want to steal for the SSID. Oh, well, let's do that. So, of course, that makes sense. So this is where the design aspects of being a developer have to come into play, I guess. Here's what I'm talking about. Let me clue you back into my train of thought. For the settings, I have two settings. I have network settings and I have the actual server settings, the server being this. So I'm going to create two boxes. I'm going to create a panel that looks like the CPU panel, and it's going to have the header here will actually say SSID, and then I'll have, or no, actually it'll say maybe network. No, it'll say Wi-Fi. We'll figure out something. And then inside there will be the SSID and password fields. Okay, so that's cool. Let's do that. And then I'll have a second box. So let's do this. I need to steal the CPU panel. Where is my CPU panel? There we go. Where'd it go? Draw CPU panel. There's basically where we're drawing the whole thing. Let's just steal that bit. This is all the code that draws our base of our CPU panel that we're looking at. And I'm going to paste it into here for my SSID panel. Do I need to change my font? Yeah. And now I just update a few values like the theme. Oops, everywhere that says that, I just replace it to my new theme. Change my X and Y to SSID. Okay, so now I have a box, and now I want to change this to be S This is vertical, so basically that I need to go down another 6. What am I doing there? 25 to 47 is what? 22? 22, 69, 70, 71, 81, 91. So this should be 91. But I think that's going to put it too low, so let's move the whole thing up to, let's say, 15. So I dropped it 10. So 3, 6, 5. Oops, nope, just 5. And this should be 8, so that'll move it all up a little bit. It now says SSID. Oops, that's not right. That should be X and Y there. Width and height, I'm just going to leave for now because I don't know how big it's going to be. Okay, so draw my SSID panel. I got to make a call to that up here. Okay, so that should just give me my SSID box. Let's go have a quick look at that. Doing some compiling in VS Code, takes forever and a day. Okay, so now we're just going to make the box. Once the box is built, the next step is to put a label in there, SSID. You know what? Yeah. You know what? Yeah. Okay, backing up. Okay, yeah, we'll just let that compile. Okay, so I'm going to go to my RAM panel. Where's my RAM panel? On my home screen. Let's go have a look at the RAM panel. This is a better selection. I should have done this the first place. RAM, mem, net, time. What the hell? GPU. CPU, GPU, mem panel. Just pushing the button and letting things upload. Just want to see the little box that I made, you know, and the red theme. This is a good opportunity to see if that red theme is actually going to look any good. Who knows, the red theme might just suck. Oh, push the button. Okay, boot this into Bluetooth configurator mode. There we go. There's our disgusting little red button. Okay. I don't want to do that anymore. I want to do something different. HDD panel. Here's what I want to do. No, bad choice. Gonna go back to the home screen and have a look. I don't want to. What I'm thinking is I don't want to do the vertical, the header. I don't want to do a vertical header. Okay, I don't want to have a vertical header. I want to do a horizontal header. So I got to find one of these widgets that I've already built that has a the net panel. What the hell's my net panel? Well, that's a widget. I think the net panel is a widget. Yeah. No, it's a panel. Net. I'm just going to just steal some code. That's all I'm trying to do. Nah, I don't want to do that one. There's got to be a better option where I don't have to rewrite any code. So the net panel and the RAM panel are both based on the same base panel. Oh. What the hell? Did I break it? Why isn't my touch working? Well, that's weird. Did I screw something up? I think I just introduced a bug because my touchscreen wasn't working. How did I break it? Oh, wow. For some reason, my touchscreen no longer works. Well, that's just annoying. I wonder What did I do here on my Bluetooth configurator? Did I do something bad? I'm just going to take all that out. Because something is weird. Something is really weird. Something is really weird. Huh. Alright, that's just weird. Why didn't the touchscreen work anymore? That's just weird. Come on, build already. Take your time. Don't take your time. I'm really thirsty. I feel like I'm coming down with a cold or something. Not good. Alright. It really slows you down, this build time. Okay, there we go. Upload the new code. So I just took out the Bluetooth configurator screen just to see if that's actually breaking my touchscreen. I don't know why it would. Did I do something to the home screen that I shouldn't have? Just hit Control Z a few times on here. It doesn't look like it. Okay, so it's loaded. Okay, so the touchscreen does work. So let's go back to my display handler and let's put some of these back in. But not the update. Let's leave the update out. So we'll just create it. Now, obviously it's not because running it is causing a problem, but doing something with one of those variables somewhere is, I think, stepping on some memory somewhere, and I just have to see where the likely culprit is. It's not a runtime thing, like, you know, not having, because when I'm on this, I mean, that class isn't even instantiated, so it doesn't matter. But it does matter when you're compiling and uploading this that it's not accessing a variable outside of a scope or doing something bad, stepping somewhere. Which I think it did, and holy cow, why am I so dry? Come on, upload already. Oh boy. Come on now. You can do it. No, really, you can. Sometime today. Thank you. Now I gotta push the button. There's the button. And now we gotta wait for the upload. And there's the upload. Hoi. Hoi. I'm sure that my build directory is configured. Yeah. Okay, touchscreen works. So, I don't know. Could just be I did something else and I broke something else for a minute, but obviously it's not an issue. Let's just put this all back. Let's go check the update screen. I don't have anything to delete, do I? Yes, I do. Let's just check the home screen and see if I'm actually... Where's my destructor? Right there. Net panel, mem panel. Yeah, I haven't done any of that stuff yet. Wait, have I? I didn't instantiate any new variables. There's no new pointers. Yeah, let's just do an upload. It should be fine. I thought maybe I wasn't destroying a variable, and that can have a bad effect. But again, it didn't actually run the screen, and it wouldn't have an effect. So no, that wouldn't be it at all. But I gotta wait for another compile time. So, I want to change this to use a horizontal header, and I have an example here somewhere. Where do I want to use it? Oh yeah, right there on my CPU screen. The draw package, no, just my header. Where is it? Where is it? Come on. No, let's just pop up to the, still, you're not looking at what I'm looking at. So I'm looking for the code that writes that horizontal header. Alright, let's just reboot the thing. Okay, where is it? Package? No, here. Fill screen, text on the font, package panel. Yeah, touchscreen works. Okay, so package panel. There it is. This is what I want. I'm going to take that. Okay, finally found what I'm looking for. Put it over here. And I'm going to change it to this. Go to my header panel, pull up my little things here, put X there, put Y there. Got to change this to my theme. Just a bunch of cut and paste coding. I'm going to change this to network. NETW. I'm going to leave this at, no, I'm going to leave that there. I'm going to make this a little narrower. Let's say, let's just go to 100 by 60 for now. That draws that. This draws the header. Sure, network. What is this sprite for? Oh, that's the actual header. Now you'll notice every time you use this, you have to call create and delete. You must manually delete your sprite every single time. It's not a bad thing. This is all about memory. Remember, we are trying to stuff as much action as we can. That means we're going to actually take a hit and just having to do a manual statement like this. If you forget it, you end up with a memory leak. You'll figure it out soon enough. You must delete. Every time you create, you must delete. Or you run out of memory real fast. And bad things happen. Okay, so I think that's it. Network, local chords. Okay, let's just do that and see what it looks like. This is my new Bluetooth screen. And then we're going to put in 2 labels for SSID password. We'll read the data off of the file system with a little bit, and we'll fill that in. And then when the serial object actually updates it, there's a function there somewhere that writes to those fields. That field will actually dump a item onto the data display queue, and that'll actually trigger the text update. But we gotta wait for that to build. Did I do something wrong? Did I do the wrong button? Did I hit the button? No, I hit the wrong button. Waiting for it to build. Okay. While that's building, let's see what's happening in the world of tweeters. Backside, front side. Lando Norris has his ball cap out. What it was. Yeah, they're still talking about Mercedes AFG's new livery. Oh well. Ferrari, yeah. Still compiling. Lots going on with Ferrari, Mercedes, and what's at the top of this list? Nothing. Okay. Oh, what do we got? Action! Push the button. Is it doing it? Yeah. Come on now. Two hours and 20 minutes for this stream so far. Okay, gotta go see what that looks like. Okay. I did not do that right. That's okay. Well, let's have a look at the code and see where I went wrong. Why would that be wrong? SSID panel. Where's my home screen? Where did I steal that code from? I stole it from the GPU screen, didn't I? Configurator. Where? I thought I had that file open. Game screen. What was I looking for? This is my game screen? No. Yeah. Is that what I wanted? Game screen. Temp panel. No. Where did I steal that code from now? Anyways. What's going on here? I changed the number, didn't change a different number. That's what I did. X. Oh, that's width and height. Right? That's why, yeah, width and height. Okay, so I need to change the width of this box too. What was that previously? 320. Where we got fill rect. Oh yeah, well that's what I did wrong. Wasn't paying attention to the variables I was changing. So have a close look at what's going on there. Okay, so yeah, the inner box is not the right size. Okay, so I made that one 100. Let's make it 100. All right. So let's make that 120, which is 200 less. Yeah, so this one I wanted to be X, Y width. Whoa, what size is this? 48, 120, 112. What is this? Create sprite? That's a pretty big sprite. What should be? Okay, well I'm going to leave that one for now. I'm going to show you a trick for debugging how some of these outlays look. When you're dealing with the TFT and you're trying to draw stuff, I'll show you a trick for making it easier to figure out what you're doing. Now, when I do this, I'm going to compile. Oh, fuck. That's right. The trick isn't going to work because it takes so darn long to actually compile and upload anything. What are we at here? Come on and build and build and build. Wow, you know, that's just really is annoying. It takes so long. I think I made a mistake on the screen because I'm not using relative coordinates. Yes, I am. Yeah, I set up my local coords object. I draw a box with it. I draw a box using my local coords, and then I fill a rec. This should be my, yeah, this is my header. This is my darkened header, right? Panel header color, yeah. So off by, yeah, local cores, 3 to 4, but it should only be, yeah, that's right, that's the right width. Right, yeah, so now the inner box is the right size, but I didn't change my my header box. And I'm going to change the color of it too. And I think I want my text to be smaller. Okay, where's my header panel? Right here. Create sprite, 128. That's too big. So the inside rect is 112. This needs to be 112. Panel header. What do we got going here? I'll click words. So draw the big box. Fill it in. Yeah. And then we set our text datum and our colors. Yeah. We create the sprite. So this is our text sprite. Oh no, this is our header color sprite. So this thing has to be 112. And then we draw text onto it. It says network at 0, 0, and then we paste this. Why at 36 and 6? That's weird. Width and height. This should be bigger. This should be, well, windy. Let's try this at about 20. And you know what? I want to make my header color darker. So I'm going to go back to here and change my header color to that. Yeah, let's just see what happens there. And then compile it all again. So I just changed my header color. I used that color picker again, and I picked a darker color, and then pasted it into my header file as my new H color. So now I'm compiling and building it again. The idea is that this will just be a small box, probably centered later on. It says network, and then it'll have SSID, and then whatever the network name is I'm connecting to, and then password, and then it'll be stars. If there is a password set, it'll just be stars. If not, it'll be blank. But in the meantime, we're just waiting for more code to compile. GT World, Black Mesa. What's going on here? Uploading, fine. All right, now back into the screen. But that just takes such a long process. Okay, so now my header is still too wide. It's such a long process just to come up with that little. Come on. All right. So different IDEs are just, you know, I don't know why people use VS Code. Where am I? Changing my header size. Okay. What am I doing here? This is, yeah. See, I think it's that one that's, why is it being pushed at that location? No, that's right, network. But it's just too wide. 112 is too wide. It should only be, yeah, see, because I'm pushing the local course 36, this should be a lot narrower. However, I should actually just change this to, why should the text be top right? If I do that top center, yeah, and then I can make this, why did I do it this way to begin with? I don't want this to be 112 wide. This should only be just wider than, yeah, this should be 112. The same width as the rectangle. And then this should actually just be the same offset as 3 and 4. because now I'm printing the text centered in the sprite. So if the sprite is the same width, fuck's sakes. So I'm just changing this text around, changing my datum to be top center. This means that when the text, your cursor point, instead of being at the top left and then the text coming out, the text will be printed at, but it'll actually use a center point, so your text is evenly spaced around that center point. So if I create a sprite to be the same width as my box, I have my text datum to be top center. Anything I type will be centered in that box, and I make sure that I actually draw or push that sprite to the screen at the same starting location as my box. Therefore, this should actually end up being centered at the top of the box. Any bets? Think I can do it? What am I doing? I'm pushing the button for another long verifying build process. That makes me sad. Yeah, so much faster at Visual Micro. I'm going to complain about this until I manage to raise $25 and buy a Visual Micro license. So I'm on, don't forget you guys can subscribe to my YouTube channel. Turn on notifications so you can see when I'm going to be going live. Over the next few days, I'm going to be finishing this project. Not only will I be finishing this code, I'll be finishing the design of the circuit board, making the circuit board, soldering all the components, ever finishes verifying and compiling so that it uploads and I can get past this one damn step. Thank you. Okay, back to the Bluetooth screen. And, well, it almost worked. My text isn't centered, but why isn't my text centered? How big did I make the box? 112. Top center. I filled it. Pushed it. Why isn't it centered? No, I'm using the right one. Okay, well. Where's my box? That's the other thing I'm missing, is a box. Okay. My game screen, temp panel. Temp panel, mem panel. Oops, mem panel. Mem panel. There we go. That's the one I wanted. Where are we here? Draw panel. If small. Oh yeah. That's the dual sized. Let's go with this one. Nope, don't want to use that one. Let's go back to the mem panel. Let's just steal this. Because something is not right. So I'm going to try something real quick. Which one is this doing? Draw the box. Okay, I actually want to use this as my, I'm going to put this down here. I think this is what I'm doing here, local chords. I want to use local chords. There. And there. What the hell is text sprite H? I hate it when I get fancy in some of this code, and I try and do things programmatically, and you guys aren't even seeing what I'm seeing. Man, you gotta yell at me sometimes, man. Okay. So I just need to move that over a bit, right? Yeah. 36 is too much? What's the whole total width of it? 112. And then we'll just compile it again and wait forever. Wow. All this just to get one little box up there. I had a different idea, though. I had a different idea. No, don't want to do that one. What did I want to do? Let's try the net panel. It's the dual size too. Actually, that is what I want to use. You'll see what I'm going to... Okay. What are we doing here? Oh, I get tired of having to do this every freaking time. Especially when I want to change my mind. It's not as convenient as using Visual Micro, that's for sure. Is it uploading? Why didn't it reboot? What the hell's going on? I think something has gotten horribly wrong. Because that's not updated. Okay, I think I've just lost a camera, ladies and gentlemen. Why? Let's try that again. I've lost a camera. What's going on here? Yeah, it's definitely not having a good time. I wonder why. Well, that's weird. I lost my overhead camera. I think maybe it got a little hot with this light shining on it. Because it's actually feeling a bit warm. But whatever. See if that works. Nope, still not working right. Okay, well, you know what? This has been a tremendous learning experience for me, so I know what to do better next time. And since I just lost a camera, well, I just lost that camera. I think I should still have this one running. I can see it. So this has been a tremendous learning experience. I've got a lot going on here. I need to take a break. My throat is killing me, and I'm sore. I lost my camera. So I'm going to take a break for a couple of hours while I resort out a few things, see what's going on, and then we're going to finish this Bluetooth panel. And I'm going to take a couple of more shortcuts and do some more things. Anyways, this has been a tremendous learning experience. I guys hope you guys like what this HardSense project is, and you kind of figure out what it is going to be, this remote display. There's still a lot of work to go on it. I just want to get, thank you, I just want to get to the point where it's actually a finally packaged product, because the rest of the code that's going to be written and updated can actually be deployed through OTA or over-the-air updates. So I won't even have to plug it in anymore. And that'll be part of the ending of this project, because there's a lot more code to write. First of all the sensor data that I'm streaming to it is hard-coded from my computer. So you'll notice that all of these sensors, where is it? There it is. It's actually like, if we have a look at, So Intel CPU 0. The hardware or the sensors that the ESP32 is requesting to display are very specific to my computer. I want to change that and make these actually configurable by a text file that can be uploaded. Either through the Bluetooth settings, there'll be actually a key value mapping files. This way anybody can actually use this without having to write new code. You just turn it on, connect to your Bluetooth, go to your settings, your Bluetooth configurator, and you can update. You can use this to actually say, okay, on this screen, like on my home screen, connect this value to this sensor string, and that'll solve a lot of problems. But that's after. I just want to get this back built onto circuit boards and into a box, and that's where we're at. So I don't know what happened to my camera. It's really unfortunate. I'm just rebooting it to see if I can get it back. But I think it's time to take a break because my throat's killing me. And all of that good stuff is going. Where's my. So I'm just trying to get this camera back up. It's going to take a minute to load. Okay. So look for me again in a couple more hours once I get a few things sorted out, and we'll finish off these new screens and make them look good. I'll try and go faster, but you know, this compiling that this takes so long. Oh. Come on now. Oh, let's see, did I get it up and running? Hey, look at that, it's back. Oops, I did that wrong. I want to hold this button down. Oh, what am I doing wrong? There we go. Yeah, see? That's not right. I made that widget too wide. Anyways, I hope you've enjoyed what's going on. You kind of see what's going on. We're going to have a lot more fun with this stuff. Building circuit boards, building 3D printable boxes in Fusion 360. I'll show you how to take designs, your circuit boards from from KiCad and actually get them into Fusion 360. It's so easy when you're making a box for a circuit board that you've made in KiCad, because you can actually just take that circuit board into Fusion 360 and design your box around your circuit board. And you'll have the full proper representation of all your headers, chips, diodes, everything. It's all there. It's beautiful. I love it. So thank you all for watching. And I will see you all in a few more hours. I really had a lot of fun here. I hope it's fun for you. Okay. What do we got going on here? Anyways, thanks again, y'all. Say goodnight.
Shut up and sit down.